on section 411.3. I'm getting confused between what part of the book I'm in. Section 11.3, problem number 25. So let me work that one out real quick, okay? We are section 11.3, and it is problem 25. And we are asked to consider the possibility of what the geometric means would be, not just in the real number system, but also in the complex number system. So if we're working, if we could be in, if we're doing complex analysis, right, we would want those possibilities. All right, so we want three geometric means between two, three geometric means between 2 and 162. 162 here. All right, well, to find the geometric mean, or the means in this case, remember we've got t sub 1 is equal to 2, and t sub 1, 2, 3, 4, 5. T sub 5 is equal to 162, right? So therefore, let's see, 162 is going to equal t sub 1, 2 times the common ratio r, and we're going to raise that to the 5 minus 1, the fourth, right? So we can see here that r to the fourth would have to equal 81, just dividing both sides by 2. Right. Okay. Now this just suggests lots of possibilities here. If we're in the real number system, right, then I can see that one of the possibilities here could be that 81 equals 3 to the fourth. So my common ratio could be 3, right? And if that's the case, then my geometric mean up here would be 2 times 3, which is 6. 6 times 3, which is 18. 18 times 3, which is 54. And 54 times 3, which is 162. So my three means would be 6, 18, and 54. And keeping in mind, a geometric mean, 6 is, the arithmetic mean between 2 and 18 would be, what would it be? 10, right? The arithmetic mean would be 2 plus 18 divided by 2 would be 10. But the geometric mean is 6 because it makes, I don't know, one of the ways you could think of it is 6 divided by 2 is the same thing as 18 divided by 6. Do you see how it makes the common ratio 3. And so that's why it's the geometric mean, because it makes that common ratio. So I don't know, hopefully that just kind of a little bit explains what a geometric mean is. All right, well here we are, that's one possibility, or we could look at this one right here. We could say negative 3 to the fourth, right? Because negative 3 to the fourth is also 81. So then my common ratio could be negative 3, and that would cause me to have the series. It'd be 2 times negative 3, which would be negative 6, times negative 3 would be positive 18, times negative 3 would be negative 54, and then positive 162. All right, that's what happens if I'm in the real number plane. If I'm in the complex number plane, okay, let me erase those just so they can get them out of the way just a little bit. If I'm in the complex number plane, then I could have this, right? 81, another way I could get 81 would be 3i to the fourth. This would be another possibility. And just to convince yourself it works, it's 3i times 3i, right? Times 3i times 3i. This is going to equal 81, right? I squared times I squared, and if you remember, or you could remember what I to the fourth is, I just can never remember anything but I squared. So this is going to be negative 1, right? 81 times negative 1 times negative 1, which is positive 81. So do you see? So do you see that works? All right. Well, keeping that in mind, my common ratio then would be 3 would it be common? Yeah, my common ratio would be 3i. All right, so that means it would be 2, and then so in the complex number plane, right, it would be 2 times 3i, which would be 6i, right? And then 6i times 3i would be 18i squared, right? 18i squared, which would be negative 18, right? And then it would be negative 18 times 3i. I could do these over here or something because it's just hard to do them in your head. This is going to be negative 54i. This is going to be negative 54i right here, right? And then you can see here, if you multiply it again times 3i, right? I would get negative 162i squared. So you can see that we'd get a positive 162. All right, just to confirm. So that's a possibility, right? I mean, that would work. And you could just see here, so my three means would be 6i, negative 18, and negative 54i. Now there's another possibility. we're not done, right? The other possibility would be 81 could equal, I think it's this negative 3i raised to the fourth. This will also work. If you take negative 3i times negative 3i times negative 3i times negative 3i, you also get positive 81. So we should look at this possibility too and see what we get here. All right. And so with this possibility, let's see, we would get 2, of course, is our first one. It's our first term. It's a given, right? 2 times negative 3i. Here, we'll just kind of build it up right here. 2 times negative 3i we can see is negative 6i. Negative 6i. Okay, and then we're going to take negative 6i times negative 3i, and it looks like I'm going to get positive 18i squared, so negative 18. I don't even get an I in there, right? And then I'm going to take negative 18 times negative 3i, and I get 54, looks like positive 54i. All right. And then I think 54i, and I hope I get the right thing here. Let's just make sure. We're going to take 54i times negative 3, what would it be? Negative 3i? That's the common ratio, negative 3i, yeah. And that's going to equal negative 162i squared, ooh, which is a positive 162. Sweet. It had to work. I don't know what we'd done if it didn't. Negative 6i then, negative 18, 54i would be the other three geometric means. All right, so that's, you know, that would be all of them. I erased them, but hopefully you all can keep track of all of them. I'm running out of some battery here. All right, so hopefully that makes sense, and you all have a wonderful rest of the day. Bye.